Hi everyone, hope you're doing well. This is a video to go over the January 2019 Algebra 1 Regents exam. Please make sure you post all of these pages on Google Classroom so you get credit for it. Hopefully it wasn't too bad now that you've done a couple of Regents. Again, January, it's not as hard as June is, but it's not as easy as August is. And it's usually not horrible, but there's usually a couple questions that are just kind of weird that we've never seen before. But all right, here we go. First page, let me zoom in a little bit. So number one, the scatter plot below shows the relationship between the number of members in a family and the amount of the family's weekly grocery bill. So the most approximate prediction of the grocery bill for a family that consists of 6 members is, so basically it's a scatter plot. You want to make the line of best fit through it, make sure it's in the middle of the dots, and you're going to go up and over, and the closest that it is $300. All right, number 2, the function g of x is defined as g of x equals negative 2x squared plus 3x. What is the value of g of negative 3? So basically, I just plugged it in. Be careful, you have to use parentheses over here, and I got negative 27. You could actually also have done it in the calculator. So can also do in calc. So put equation into y equals. So if you put the equation into y equals, okay, let me get all of this out of here, and you put in negative 2x squared plus 3x, and then you go to the table and you go to where you see, let me just change my window really quick. You go to where you see negative 3, the answer is negative 27, so it actually gives you the answer for you. So always make sure that you have your calculator handy and you're comfortable with that y equals. All right, number 3, which expression is rational? Okay, which expression results in a rational number? So basically, I just put all in the calculator and I got answers. This is like 6.417424, blah, blah, blah. This is 35.35533. All these keep going. This one is the only one that came out to be a nice number, 0.4. And this one keeps going 11.1803398. So if you notice, the only one that's different than the rest is number 3. That's the only one that was your terminating decimal. Okay, so terminating decimal. Remember, terminating is what is the definition of a rational decimal. So that is the answer, number 3. Okay, next page. All right, number 4. Again, I'm going to zoom in a little more. There we go. The math department needs to buy new textbooks and laptops for the computer science classroom. The textbooks cost $116 each. The laptops cost $439 each. The math department has $6,500 to spend and purchase 30 textbooks. How many can, okay, so this one is our number plus number equal number, money plus money, but money equals money, but it just looks a little bit different because we didn't have to solve for anything. We didn't have to solve for the amount of textbooks. They already gave it to us. So X is textbooks, Y is laptops. So we're actually going to put X in for 30. So we're going to use the one where we have the money plus money equals money. That's what we're going to use. And because this is part 1, so I don't really check your work anyway, but I actually use an inequality because that is actually more correct. Okay, so you have 116 times your X, which is your 30, and then you have 439 times your Y. So I multiply those, and then I solved, and I got Y was this decimal. Now it says, how many laptops can they buy? So you can't buy a portion of a laptop. So you need a number that's less than or equal to 6.8. That would be 6. If you tried for 7 laptops, that would be no good, okay? I'll just show you that really quick. So 116 times 30, we already know is 3480. So if I do 439 times 7, we get 3073. So if I add that to 3480, you're going to see that I get a lot more than, well, not a lot more, but I get more than the 6,500, so no good. So 7 is too much. Okay, because again, we'll do this plus 439 times 7, and that got us the 3480, and that got us the 3073, and then that got us the 6553 was not less than or equal to 6,500. So if you got confused and picked 7, that's just your proof as to why 7 was too much. All right, number 5, it says, what's the solution to the equation? So basically, you're just doing DCMS. You're going to distribute, use your alpha y equals, and when you solve, you should get 0.4. Number 6, the area of a rectangle is represented by 3x squared minus 10x minus 8, so it's trinomial. Which expression can be used to represent the area of the same rectangle? So basically it just had you factoring it, but it was just a weird way to ask it. So tricky trinomial, 3x and 3x, 3 times negative 8 is negative 24. What multiplies a negative 24 and adds to negative 10 is negative 12 and 2. Simplify, make sure you must simplify. Must all right, try that again. Must simplify tricky try. Must simplify tricky try. And actually also, don't forget I did teach you the new way, factoring by grouping. That works too. So the answer is number 1. I did put that tricky try factoring. Oh, that's what it was. Can also check in y equal to see which table matches. So remember, this y equals is awesome. It really gives you so many answers on your multiple choice. So 3x squared minus 10x minus 8. And then, okay, try that again. 3x squared minus 10x minus 8. And then you obviously try all of them. We're just going to put the answer in. 3x plus 2. And then x minus 4. And then when you go to the table, you're going to see, look, the numbers are exactly the same. So you know that they mean the same exact thing, or they are the same exact thing. Okay, so look for where you have matching tables. So you want this one to match this original one. All right, 7, which relation does not represent a function? Remember, function, each element of the domain does not correspond. Oh, well, this is does not, so we want does not. So each element of the domain does not correspond to an element of A. So the x values do repeat. So you're looking for which ones the x values repeat or fails the vertical line test. That's what we're looking for, okay? So this one, 1, 2, 3, 4, 5. So this one is a function. So this one is okay. No repeating x values. This, if you put it in the calculator, you're going to see your square root graph, and this is going to pass the vertical line test. So 3 radical, oops, let's move that up to the top. So 3 radical x plus 1, all are underneath. X plus 1 is all underneath. A minus 2 was the outside. If I graph it, you'll see that it passes my vertical line test. Okay, so I'm going to write passes vertical line test. Vertical line test. So this one is good. This one passes the vertical line test. So that one is good. And now your last one, this is good. This is your mapping. Okay, this is your x and this is your y, or your domain and your range. Okay, I'm going to write mapping over here. If you match them up, 1, 4, 1, 5, 2, 6. I mean, you could even hear me saying that x is repeated over, so that's no good. So it is choice 4. X values repeat, no good, not a function. 8, Brittany is solving a quadratic equation. Her first step is shown below. Which properties? So from here to here, the first thing you notice is the order switches. Order switching is always commutative. And over here, you distributed. So commutative, distributed, 2 and 4, choice 4. Number 9, the graphs of y equals 1/2 x squared minus x minus 4 shown below. So you have a parabola. The point A, which is negative 2, 0, B, 0, negative 4, and C, 4, 0 lie on the graph. Which of these points determine the zeros? Remember, zeros is also known as your root solutions or your x-intercepts. So you're looking for the zeros where the parabola intersects the x-axis, okay? Where the parabola intersects the x-axis. That's what you're looking for, and those would be your answers. Okay, so those 2 points where they intersect the x-axis would be A and C only. So number 9 is 3. All right, hopefully you're doing okay. Number 10, given the parent function f of x equals x to the third, so that's your cubic, and the function g of x equals x minus 1. Okay, so basically you have a parent function and then one that moved. So cubic parent function. And you guys are so awesome with these rules. Negative on the inside actually means right. Negative on the outside means down. So that is choice 3. You could even actually put it in the graph and calculator, the graphing calculator. X to the third, and then x minus 1 to the third, and then a minus 2 on the outside, and kind of just graph it and see what happens. So you have 1 there, and then you're going to see that it moved to the right. This whole thing shifted to the right and shifted down, okay? So I'm going to write that. Can graph on y equals to check. I'm going to write, can also graph on y equals to check. I think that's a little bit better. All right, number 11. If C equals to, C is a binomial and D is also a binomial, so you want to just do this. So you're taking C, which is 2a squared minus 5, and you're subtracting twice D. So twice, make sure you put this D in parentheses, it is a binomial. Then you're going to distribute and combine like terms. And actually, yep, choice 3. There you go, that is the answer. So that wasn't too bad. That was just a polynomial question. 12, Mark bought a new laptop for $12.50, so that's his principal amount. He kept track of the value of the laptop over the next 3 years, so year 1, 2, and 3. So if you notice, these go up by 1. Okay, oh, actually, all these are exponential, so we already know they're going to be exponential. Okay, so for exponential, so this is the original price, right? And R is a 20% decrease, okay? So 20% decrease. I also figured out the R by what the actual, R is itself by taking those two numbers. So I did 800 divided by 1,000 and I got 0.8, which actually matches this right here. Okay, so if you look at all these choices, these are ones that are saying that 1,000 is the original price. That's no good because 12.50 is the original price. So it has to be one of these two. Now, do these numbers increase or decrease? These numbers decreased. So this is the only one that's showing decrease. Okay. You can actually also, okay, yeah, so this one's no good. That one would be increase. We are decreasing by 20% to get 0.8. So you can actually also put this in the calculator. So if you go to stat 1, clear out what we have here. 1, 2, 3, and then 1,000, 800, and 640. Again, we already know that it is exponential. So we're going to go to stat, move over to calc, and then we're going to go to number 9. It's going to give us the answer. So stat, move over to calc, go to number 9. Nope, try again. We're going to go to 0. Sorry about that. Number 9. 0. Exponential, right? Press enter. And it's going to give us the numbers, right? So saying 1250 is what to start. That's your y-intercept. And then 0.8 is going to be the base. And there you go. Answer. So starting value / y-intercept. And then that is your base. So I like this way better, actually. Just go right to the calculator and let it kind of get it for you. So stat, calc, exponential reg to get the equation. And remember, you can also get the answer by plugging these equations into y equals. I wrote here. Can also plug into calc, y equals, to check to see which one produces the table. So what you would do is you go to y equals, and I'm just going to put the answer in to show you how it works. So 1250, and then 0.8 to the x, and then you go to the table and you just look for these numbers. So 1 is 1,000, 2 is 800, and 3 is 640. So you can see by putting into y equals, you can get the answer that way too. So that's just another way you can get your answer. All right, 13. The height of a ball during toss into the air can be modeled by the function h of x equals negative 4.9x squared plus 6x plus 5. X is the time elapsed, so x is our time. And this is h of x, which is going to be your height. Okay, let me write height and not distance. It's going to be your height. What does this 5 represent? Okay, so 5 is going to be choice 1, the initial height of the ball. Okay, if you put this into the calculator and you kind of look at it, let's erase what we have. Negative 4.9 x squared plus 6x plus 5, and we graph it. This is 1, this is 2, by the way. You're going to notice that 1, 2, 3, 4, 5. So it starts at a height of 5. It goes up, and it looks like it's like, I don't know, like 3/4 is its height, his max height. Then by 1, it's already coming down, and it's hitting the ground again a little bit closer to 2. So that is going to be the initial height of the ball, 5. It reaches the ground. It can't be that because it reaches the ground over here, okay? The time, okay, so the time is like a little less than 2 seconds, so that's not even good. Time, which is the highest, nope, we said time was the highest, is like 0.75. Max height of the ball attained, that height is set 5, 6, around 6 point something, and you can actually see that from the graph itself. See how it goes up 6.1 and then starts coming back down to negative, so that's no good either. So the answer is 1, the height of the ball. And it's kind of the y-intercept too. we could think of it that way, at that number, because this is technically our y-intercept, so if that helps at all. All right, number 14, moving right along. The function f of x equals 2x squared plus 6x minus 12, a domain your x values, from -2 to 1, inclusive, so you want to include those. So what's the range? So the easiest way is to go to y equals, put this in, 2x squared plus 6x minus 12. Okay, it wants us to go from a -2 to 1, so we have that here. So -2 is -16, -1 is -16, 0 is 12, and 1 is negative. So we have our y values, but what's really tricky, you have to remember, don't repeat anything. Put them in numerical order, don't list the repeats. So it's -16, -12, and -4. 15, what equation has the same solution? So these are already set up for you in vertex form, so you know you want to complete the square. So complete the square. It must be equal to the c. So I'm going to add the constants, okay? I'm going to add 8 over 2 to both sides. Remember, that's b over 2 squared to both sides. This value right here is half of b. And then I combine 33 and 16 to 49, and that is your answer. It's a little harder to do it into y equals because this is equal to 49. You'd have to subtract 49 to get it equal to 0. And that's really the only way you can check it. So x squared plus 8x minus 33. So again, if you like using the calculator, make sure that you're plugging it in, x plus 4 squared, with this constant mover. It has to be equal to 0. So minus 49, and this should get us our two tables to be exactly the same, which it does. So just be careful with that if you're going to plug in the calculator. All right, 16. This is an interesting question. The table below shows the weight of Liam's pumpkins, L of W, Patricia's pumpkins, P of W, over a 4-week period where W is the number of weeks. Liam's pumpkin grows at a constant rate, so constant is always linear, always. Patricia's grows at a weekly rate, approximately, so anything with a percent is always going to be exponential. So this one keeps going up by 3.1, and we had to go to talk about 13, so I just kept following it to 13. I thought that was the easiest way to do it. And this one kept increasing by 52%. This one's a little more annoying to figure out, but there you go. Those are your numbers. So let's see. Assume the pumpkins continue to grow at these rates through week 13. When comparing the weights of both Liam's and Patricia's pumpkins. Okay, so Liam's pumpkin will weigh more in week 10 and 13. So week 10, it definitely weighs more. Week 13, no good. All right, choice 2. Patricia's pumpkins will weigh more in week 10. So let's see. Week 10, nope, we already know that she's less, so that's out. Choice 3, which is the answer. Liam's pumpkin will weigh more in week 10, so yes, very good. And Patricia's is more in week 13. Yes, that is your answer. So easiest way is just continue that growth chart. All right, 17, the function f of x is graphed below. The domain, which is your x value, so that's left to right. Okay, so look left to right. So here it starts at -1, and right as it's going up, it's going to keep going out. So that's -1 to infinity, or x is greater than or equal to -1. 18, which pair of equations would have -1, 2 as a solution? The easiest way to do is you just put this right in the calculator. Put it right in the calculator and look for where the y1 and the y2 are exactly the same exact thing. And that would be choice 3. I'll just show you how that works. Okay, for number 3, x squared minus 3x minus 2, and then I keep putting in the wrong one. That's okay. 4x plus 6. We're going to go to the table and for -1, and those 2's match, which they do, and that is choice 3. All right, 19, which function could be used to represent the sequence? 8, 20, 50. Okay, so first of all, you have to notice that this is geometric, okay? It's going up by a constant ratio, not a constant difference. And that ratio is 2.5. You just take 20 and divide it by 8, you get 2.5. So it wants an equation. If you notice, all of these are recursive because it's n minus 1. So recursive, you need a sub 1. And you need r. So a sub 1 is 8, r is 2.5. So we have a sub n equals a sub n minus 1 times r. You would have to memorize that formula on the Regents. A sub n equals a sub n minus 1 times 2.5. So 2.5 was your r. And then don't forget to say where a sub 1 equals 8. And this one, all they do is they just reverse the order, which is totally fine. Multiplication is commutative. So reverse the order and you get a sub 1, the same exact thing basically. The 25 times a sub n minus 1, and then we're 8. A sub 1 is 8, so that is choice 2. All right, moving on. 20. The formula for electrical power is as follows. So they love to use formulas all the time when they do literal equations. All right, so we are solving for I. So first you want to divide by r, and that's going to get us the I squared by itself. And you have to take the square root of everything, and I equals square root of p over r. 21, so that's choice 2. 21, the functions f of x, q of x, and p of x are shown. So f of x is this, q of x is up here, and p of x is here. When the input, so that's your x value, which is 4, which functions have the same output. So when x is 4, y is 3. This I put into the table, I put into y equals. So put into y equals to get. This one also was 3, and this one is also 3. So all of them have the same thing. So choice 4. All right, 22. Remember, as we get closer and closer to 24, it's going to get more difficult. So using the substitution method, so it's telling you what to use. Vito is solving the following system of equations algebraically. Which equivalent equation could Vito use? All right, so when you do substitution, and it's not set up for substitution, what you want to look for is you want to look for the one of the two equations where one of the variables is completely by itself, meaning the coefficient's 1. And that'll be this up here. So because we're going to use this one over here, the coefficient's 1, I want to solve for y. That is the easiest way to get rid of all the fractions. And I even showed it over here, doing it with a fraction, and it just becomes a total mess. So solve for y, so subtract 3x. Okay, you now get this y equals. You're going to take the expression and plug it in place of y. So instead of y, you have the binomial, which goes in parentheses, and that's that answer right there. So that was definitely a little bit of a trickier one. There may have been an easier way to use maybe even the y equals, but that's how you should have done the work. All right, 23, all about exponents. You know I've done exponents with you on 2 nows. The Regents loves to even, every time just do one exponent question. Okay, so here we go. 23. Materials A and B decay over time. The function for the amount of material A is that, B is that, and we want to know the amount. Okay, so we want to know when they'll be equal. So when are those two going to be equivalent? When is this equation going to be equal to this equation? Easiest way, hands down, put equations into y equals. Put equations into y equals and compare the tables. Okay, that's going to be the easiest thing for you possible. So if you notice, they're always the same. So that's why I picked every day. Now, there's another way to prove that they're the same if you do the exponent rule. So remember, this right here, all of this, the parentheses, the 2 and the t, everything's connected by multiplication, and multiplication is commutative. So we're going to basically use the associative property, and we're going to take this 2 and move it inside with the base. So 0.05 squared. If you now do 0.05 squared, leaving the t on the outside, you'll get 0.25. Notice that's the same thing as you have here. So that's just another way to prove that they are the same. All right, 24. This is supposed to be your toughest one. The following conversion was done correctly. What were the final units? Okay, and I kind of wrote over it, so I'm sorry, but this top miles and this bottom miles can simplify. Remember, simplify diagonally. Cross out the matching units diagonally, not horizontally. This hour and this hour. Minutes, do I have the minutes up here? Nope, so that's going to be part of it. Okay, I come over here, feet, and diagonally feet is good. And there's no inches, so we are inches per minute. So that actually wasn't bad. You didn't actually have to convert anything. They just wanted you to look at the unit. So, all right, so that was multiple choice. Hopefully you guys didn't do too horrible on that. Let's move on to part 2. All right, first part 2 is just DCMS, just solving an equation. Just be careful, or inequality, excuse me, just be careful because you have the decimals. So just watch out with all those decimals. And here, when you divide, you have 80,000 is less than x, or x is greater than 80,000. Just be careful. That one wasn't difficult, just a very tricky one. All right, 26. The number of people who attended a school's last 6 basketball games increased as the team near the state sectional games. All right, so if you notice, these all go up by 1, so I'm allowed to use the trick. I want to know what kind of function this is. So if you notice, they keep going up by 87. So this is a linear function because it has a constant rate of change on the first try. So that wasn't too bad. They also accepted that if you put it into L1, L2, that you went to linear regression and the correlation coefficient was 1, which means it's a perfect straight line, like a perfect match. So you had to say all of that. Okay, and I'll just quickly do that for you. So stat 1. So either way, the Regents accepted it. It's 13, 14, 15, 16, 17, and 18, 348, 435, 522, 609, 696, 783. So, enter. Stat calc. then you would go to a linear regression, and you would see that that correlation coefficient is a perfect 1, okay? So it's a perfect fit, so you had to say that. You had to say that you went to the correlation coefficient, it was 1, and it was a perfect straight line, perfect fit. Okay. All right. Yeah, so 26. That is it. 27. Solve x squared minus 8x minus 9 equals 0 algebraically. So that means no table. So there was 3 different ways that you could do it. The first way is factoring. You want to have it equal to 0, which it already is. So it's just your MAM's factoring, negative 9 and 1, and solve it and you get negative 1, 9. That is the easiest way. The second way, you might like this way better. It is completing the square. Okay, so you have to be equal to the constant. We moved over the constants. And you added negative 8 over 2 squared to both sides, which came out to be positive 16. You took half of 8, you got negative 4. And then you go this side. Make sure when you do the square root, you don't forget that plus or minus. That's how you're going to get those 2 solutions, okay? And then the last one, the quadratic formula, have it equal to 0. And then you just list A, B, and C. You plug it into the formula, you do all the work, and you'll get 9 and negative 1. So they all have the same exact answer. To explain it, you would just say either I factored the trinomial, you would say I completed the square by moving the constant first, or I used the quadratic formula by plugging the numbers into the formula. So whichever way you did it, just make sure you have the corresponding example or explanation, I should say. All right, 28. The graph of f of t models the height in feet that a bee is flying above the ground with respect to the time it traveled. Okay, state all time intervals when the bee's rate of change. So this doesn't say after change, so we're talking about slope is 0. So remember, slope dude saying this is 0 fun, this is 0 fun, is looking for just basically a horizontal line. So it's horizontal here and it's horizontal here. So this is from 2 to 6 on your time and from 14 and 15 on your time. So that's really all you had to write. You could also write an interval notation too. And then are we explaining? Explain. Yes. Horizontal line is slope of 0, which means the rate of change is also 0. The bee has a constant height during these intervals where the line is horizontal. So something like that. And it does say all, so you did have to put both. All right, 29. So graph the function. So this is exponential. Basically, the number in 2 in front is going to show you growth. As you can tell, this is growing. And the negative 7 means 7 units down from 0, 1. So 0, 1 is here. 1, 2, 3, 4, 5, 6, 7. Good. So just simply put it in the calculator. So you're going to press 2 caret x and make sure you get off the exponent and then do minus 7. Let's get rid of this guy. And then you're just going to copy your table. So just a couple of decimals and then copy as much as you can graph. So up to 4, 9. Make sure you have arrows because no constraints are given. Make sure you label everything, including the graph. And yeah, that wasn't that bad. So now they give you another function. They give you a linear function. This one's linear. And they want to know, is the exponential bigger, greater than the linear when x is 4? So I had to figure out this. I just put it in the graphing calculator. Put into y equals to get the values. It's just so much easier than trying to do it by hand to get the values. Okay, so here the linear is 3 when x is 4, and here the exponential is 9, so the exponential is bigger. So yes, f of x is greater than g of x at x equals 4. X equals 4, f of x is 9, and x equals 4, g of x is 3, and 9 is bigger than 3. All about justifying with math and with words. All right, number 30. Determine algebraically. That means no table. The 0. So you're looking for the solutions, roots, exponents. I feel like they use this a lot in this test, the zeros. All right, so one thing I want to point out, this is a degree of 3 because the highest exponent is 3, and that means there's going to be 3 answers. So it's not wrong when you did this and you got 3 answers. So I just thought of 2 different ways you can show it. I thought some of you would take out a GCF of 3x, and then you would do MAM's factoring for this part, and you get plus 4 and plus 3, and then you solve it. Here you get x equals 0, here x equals negative 4, and x equals negative 3. Okay, I'm also writing them this way because sometimes the Regents writes it this way. Or I thought maybe you divide it by 3 first. So just be careful over here. You have to divide the 0 by 3 as well, or it's technically wrong. Okay, then you're doing GCF. So now you have just a smaller GCF. And then here you're going to do the MAMs again. But you're still going to come out with the same exact answers of negative 4, negative 3, and 0. And that's one good thing about the Regents. You can do things a couple different ways. and still get the same exact answer. Whatever. I said you can't use the quadratic formula completing the square because this equation is degree of 3. Oh, that's good. Those two ways will only work with a degree of 2. Okay. And then you can also check it on the calculator. You can check, just put this original into y equals. Okay, so put equation into y equals, all right? And then you're just looking to make sure that the 0, so you're looking for where the y is 0, and it's those three numbers, -4, -3, and 0. All right, 31. Santina is considering a vacation and has obtained high temperatures from data from the last 2 weeks. So high temperature data from the last 2 weeks for Miami and Los Angeles. Okay. Which equation had the least variability? So this was a fancy word that we learned in our stats unit. Okay. Variability meant spread. I want to know which one's the smallest spread in temperatures. Explain how you arrived. So you can actually use all three of these, the range, the interquartile range, or the standard deviation. And basically you want to just show which one is the lowest, okay? Range is your highest. Oh, I did all three of them here to show you. Range is your highest minus your lowest. So Miami was 87 and minus 60, and that was 27. Los Angeles was 74 and minus 61, that was 13. So this, we're looking for what? Less. So the Los Angeles was the winner over here. Interquartile range is your Q3 minus your Q1. So you would put both of these, and I'm not going to do it, just save time, but you would put both of them into your L1, like we normally would, and then you would press stat, move over to calc, and press number 1, okay? So stat, you would move over to calc and press 1, and then that's where your Q3 and Q1 would, I mean, I guess it's not going to be the same because they're different numbers, but just to show you, that's where your Q1 and your Q3 show up. So this would be 83 minus 75, which is 8, 67 minus 63, which is 4. This is still a smaller one. This is still the correct one. And then this one I wrote, this is the most popular. Usually when people hear variability or spread, they still think standard deviation. So that is also on the same exact screen. We would use the population. Again, granted, these aren't the same exact numbers, so I didn't put them in, but the population 7.225, so on and so forth. And this one's 3.63, so this is the smaller one. So I calculated various variable stats using graphing calculator, and Los Angeles has the least variability. So again, I think this one is going to be the most popular choice. I think variability, most people think this. Standard deviation. So we just, put it all in the calculator, let the calculator do the work for us. But you can also use interquartile range or plain old range. All right, number 32. Solve the quadratic equation below for the exact values of x. So I showed it 3 different ways because you could do this algebraically, you could do it with the quadratic formula, or you can do it factoring, so I wasn't sure which way you're going to do it, so I showed them all. So algebraically, basically you want to get the x by itself, so you want to add 5 to both sides, divide by 4, take the square root of both sides, make sure you show that work, and don't forget the plus or minus. That's so important, okay? Because it's really 2 answers, because the degree of 2 means 2 answers. Quadratic formula, you want to make sure it's equal to 0, so you have to move over the 75. -5 minus 75 is -80. And then you just basically list your A, B, and C. You fill in all your numbers. And then you get, to basically just simplify, it gets 1280, 1250, 256, and 5 are your 2 factors. Remember, you can go into y equals, okay, let me just turn on the stat plot. Y equals, do 1280 divided by x. And then second graph brings you to the table, and you just look for numbers that are perfect squares. And no decimals, you always look for your integers. So you'd find 256, or 256 and 5, and that reduces 16 radical 5, and you'll eventually be able to simplify the 16 and 8 to get 2 radical 5, okay? And then the last way 3, factoring, again, you want to make it equal to 0. So move over your constant, take out the 4 GCF, you have x squared minus 20 equals 0, add 20 to both sides, simplify this radical, and again, don't forget the plus or minus. That is really the most important thing. All right, number 33, let's move on to our part 3s. Marilyn collects old dolls. She purchases a doll for $450. That's your initial value. Research shows this doll's value will increase. That means you're going to use plus sign by 2.5% each year. That is your rate. Okay, write an equation that determines the value V of the doll T years after purchase. So I actually showed 2 different equations because you can really use the one that we are used to using, the A equals P1 plus R to the n. This is our exponential growth formula. If you want to use that, then you actually have to make sure you have your key, okay? Because the A, really, they want us to use a V, so A equals V. And then T, we use an N instead. So so important that you have this key over here. Okay, you'd plug in your 450 as your initial. Your rate is 2.5, which is 0.025, and the time intervals just stays as N. You add them together after you change it to a decimal, and you get 1.025, which makes sense, by the way, because increases always should be over 1. So the other formula that I showed was using the letters that they want. So they wanted V, and they wanted T. And I just put here, put V equals A and T equals N, just show that those are in the same spot as our formulas, the one that we're used to using. So when you figure it out and simplify, it is the same exact thing. So the only difference really is the A or the V, and then the N or the T. Make sure the A stays with the N and the V stays with the T. All right, so now for part 2, it says, assuming the doll's rates of appreciation remains the same. So this was 2.5%. It's going to be 2.5% over here as well. Will the doll's value be doubled in 20 years? All right, so you're going to use the same rates of 0.025, and you're going to add just like you did above. So you're going to basically use the same exact formulas as you see right there, okay? And the difference is this time, for N, you want to plug in 20. Whether you use the A equals or the V equals, you get the same exact answer. You get 737.3773981, and money's always near its hundredth, so it's $737.38. Now, in order to be doubled, okay, let's think about that. Doubled means double of what this is. Okay, so right now this is 450. To double it, you times it by 2 and be 900. So did this come out to be 900? No, it did not. It came out to be less. So the answer would be no, okay? The doll's value will not be doubled. So the doll would need to be worth $900 or more to double in value, and it's not. It's only worth $737.38. So obviously, the answer is no. So hopefully that one wasn't too bad. 34. The data given in the table below shows some of the results of a study comparing the height of a certain breed of dog. Yay, dogs. All right, so write the linear regression equation. So you know this. You just plug all these numbers into L1, L2. Okay, I guess I'll show this one because I didn't really go through the other one. Okay, so again, I pressed stat. I went to 1, and then I cleared out by going up, pressing clear, and coming down. So 4.5, 4, 3.5, 5.5. 6, 3.5, 5.5, and then my y's. Let's do our y's. 41, 40, 35, 38, 43, 44, 37, 39, 42, 44, 31, and 30. Okay, so we were L1s, we have our L2. Linear regression, remember, is stat calc number 4. And then we're going to calculate, and it's going to do all the work for us. Nearest 10, so it's 1.9, 29.8. And usually what goes along with it is the correlation coefficient, that R. Don't forget to turn it on. You want to press mode, right? You're going to press mode, and then you're going to go down until you see stat diagnostics. So to turn on R, it's mode. We're going to press down till we go to stat diagnostic. And then we're going to press on. All right, so let's just go back to there so you can just see what it is. And this time it's usually a different number. Usually it's very high, but it's not. It's only 0.3. It's really, really low. So 0.3. So we want to explain what it means. Notice it didn't say context this time. So you didn't technically have to use mass and height, but I did. So the mass and the height of a dog has a weak, don't write strong because you're so used to writing strong, right? Weak positive linear correlation because the correlation coefficient is close to 0. So you could technically written the correlation coefficient has a weak positive linear because it didn't say to use the context, so you technically didn't have to. All right, so that was a weird one because usually it's like 0.9 something. All right, 35. Miranda received a movie gift card for $100 to our local theater. Matinee tickets cost $7.50 each, and evening tickets cost $12.50 each. If X represents the number matinee, okay, so matinee was $7.50 each. So that's why I have 750X, because this, what you're going to see I'm going to do is money plus money equals money. Y is the number of evening tickets, so that was $12.50 Y. Write an inequality that represents all the possible ways Miranda could spend her gift card. How much was the gift card? $100. So I wrote less than or equal to because you can spend less than the $100, but you can't spend more than 100. That's all that she has. So it has to be less than or equal to. Okay, so we want to graph it. So in order to graph it, they've got to be in slope-intercept form. So what you want to do is you want to kind of like manipulate this. So subtract 7.5x divide by 12.5. This was annoying because of all the decimals. And you got y is less than or equal to negative 3/5 x plus 8. So your slope is negative 3/5. Your y-intercept is 8. You can also do the table if you prefer. So here you were going to begin at 8, and we're going to go down 3, right 5. So down 3, 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, and you can't keep going. So it's going to end up somewhere, I guess, like a little bit more than 13, technically. I think it ends up. Make sure that you have the shading. Make sure you have the original inequality must be inside the shading, and no arrows on one of these, on neither one of them, because you can't have a negative number of tickets. So what's the maximum number of matinee tickets? So X, you're looking for here. Miranda could purchase with her gift card. Explain your answer. So this doesn't actually end exactly on 13. It's a little bit past 13. So 13 is going to be the highest amount that you could buy, because I even tried to show it here, even though you're not supposed to show negatives in the table. I want to show you that once it gets to 14, it is a negative value. So 14 is no good. So the most it could be is 13. Okay. Yeah, so that is it. 13 is a large whole number, value of X within the shaded region. You could say that it doesn't give you a negative amount, something like that. So anything like that, but just make sure that you put 13. All right, 36, we're almost done. One spring day, Elroy noted the time of day and the temperature in degrees Fahrenheit. His findings are stated below. Okay, so this was a little much. Oh, this is very sciencey. Okay, at 6 a.m., the temperature was 50 degrees. And by the way, they want us to graph it. So, yeah, at 6 a.m., the temperature was 50 degrees. So I kind of made like a little chart here. So 6 a.m. is 50 degrees. For the next 4 hours, so that means from 6 a.m. to 10 a.m., or at 10 a.m., it went up to 62 degrees. So I'm going to write 6 to 10, it went up 62 degrees. Up to 62 degrees, not up 62 degrees. It went up 12 degrees because it's 3 degrees per hour. It's 4 hours. 4 times 3 is 12. 50 plus 12 is 62. And then it says the next 6 hours, okay, so that's 10 a.m. to 4 p.m. It rose 2 degrees per hour. So I did 6 times 2 is 12, so I increased it by 12 again. So 62 plus 12 got me 74. Then it said it stayed the same until 6 p.m. So 4 p.m. to 6 p.m. it stayed at that constant 74. Then it says for the next 2 hours, the temperature dropped 1 degree. So I did 2 times 1 is 2. So it's negative 1 per hour. So it's going down 2. So 74 minus 2 is 72. And then it dropped steadily until the temperature was 56 degrees at midnight. So from 8 p.m. to 12 a.m., it dropped 16 degrees and it went to 56 degrees. So whether you just looked at it here or needed this chart, it's all there for you. Okay, so now it wants us to graph it. So 6 a.m., it started at 50 degrees. And then it said at 10 a.m., I'm just using my chart above, at 10 a.m., 62 degrees. So I went 10 a.m., 60 degrees, I made another dot, connected. Then at 4 p.m., right, at 4 p.m., it should be at 74 degrees. So 12, 1, 2, 3, 4, it should be at 74 degrees, made a dot, connect. Now it's going to stay constant, and we know it's a 0 slope for 2 hours. And then in another 2 hours, it should be 72 degrees, so it's going to go down. And then it's going to get to 56 degrees, right? These are both all by 2, 2, 4, 6. It's going to be at midnight. So that's what it looks like. A little bit weird, but state the entire time interval for which the temperature was increasing. So from here to here, it is increasing. So it's 6 a.m. to 4 p.m. And you could even check it here, 6 to 4, it kept going up by 12. So that's where it was increasing. All right, average rate of change. You have to use f of x2 minus f of 1. You have to use that. From 6 p.m., that was your x1, to midnight, that was your x2. So it's f of 12 minus f of 6 over 12 minus 6. I put the PMs. Actually, we're going to change this. Not PM, that should be AM. Okay, so at 12, we know it was 56. That's where that came from. And at 6, we know it was, what was 6? 74. So 56 minus 74 over 12 minus 6, negative 18 over 6, and negative 3. So it dropped at negative 3 degrees per hour from 6 to 12, which makes sense. You just notice the numbers are decreasing, so it makes sense that that is negative. Whew, that was a tough one. All right, last one, yay. A recreation center ordered a total of 15 tricycles. Don't forget they have 3 wheels. And bicycles. Don't forget those 2 wheels from a sporting goods store. So 15 tricycles and bicycles altogether. The number of wheels for all the tricycles and bicycles totaled 38. So if you add up all the wheels of all the bikes, you get 38. Write a linear system of equations, so that's why you see the lines here. That models a scenario where T represents the number of tricycles and B represents the number. So we have to use T and B. Okay, must use T and B. So T plus B is 15. That represents total number of bikes. 3T, right? Tricycles have 3 wheels. 2B, bicycles have 2 wheels, equals 38. That's total number of wheels. On the set of axes below, graph the system of equations. All right, so remember, B is really the y. So we're used to doing y equals mx plus b. So you have to solve for b. So I'm going to subtract t on both sides. I get b equals negative t plus 15. That means my slope is negative 1 over 1. My y-intercept is 15. So I'm going to put a dot on 15. I'm going to go down 1, right 1, down 1, right 1. I'm going to continue that pattern. Okay. Remember, no arrows because you can't have a negative number of bikes. Okay, for the next one, 3t plus 2b equals 38. Subtract 3t on both sides, divide by 2. You get b equals negative 3 halves t plus 19. Here your slope is negative 3 over 2, and your y-intercept is 19. So we're going to start at 19. We're going to go down 1, 2, 3 over 2. Down 1, 2, 3 over 2, and so on and so forth. Notice they do intersect right here at 8, 7. So that means your answer is 8, 7. 8 tricycles and 7 bicycles. If you did check the number of wheels, it does work. 8 times 3 is 24. 7 times 2 is 14. That does give you 38. Okay, but that's not what the question was. The question was, based on your graph of the scenario, could the recreation center have ordered 10 tricycles? So basically it's no. They simply just accepted the graphs don't intersect where t equals 10. Okay, so where t equals 10, they don't intersect. They accepted that. I also wrote this. I basically plugged in the 10 for t. I solved for the amount of bicycles, which was 5, and then I basically checked them. 3 times 10 is 30, 2 times 5 is 10, add it together. That's not giving me 38 wheels. It's only giving me 30. So no, because if they ordered 10 tricycles, then they would have to have ordered 5 bicycles. If you count up the number of wheels, that only gives you 30 wheels and not 38. So either way is good enough. Whichever way you wrote is correct. But all right, that was a lot. That was a lot. All right, hopefully you did okay. If you have any questions, please let me know. I'm here to help you. If not, please make sure that you post everything on Google Classroom so you get credit for it. And hopefully this wasn't too horrible. Some of it was okay and some of it was kind of tough. I definitely agree. But all right, that's it. Hopefully you have a great day. Take care. Bye.